Just like I said before, the mechanisms of reaction is simply the series of steps required for a given chemical reaction to take place. Let's go straight to what we mean by rate of reaction. Rate of reaction. Yes, rate of reaction. I want you to understand when we talk about rates, we are referring to a concept expressed with respect to time. Yeah. So rate of reaction is not that thing than the speed at which reactants are converted to products or products being formed from reactants. The speed at which reactants are converted to products or products being formed from reactant. Don't forget, mathematically, rate of reaction R is equal to change in concentration of reactant or that of product all over change in time. And of course, concentration in chemistry is measured either in mole per liter or you measure it in mole per dm cube. Then all over time, which is in seconds. Therefore, the unit of R is either you measure it in mole per liter per second or you call it mole per dm cube per second. This is the unit of rate of reaction. So it is measured in mole per liter per second or mole per dm cube per second. Of course, note, very important that 1 dm cube is equal to 1 liter. And of course, 1 cm cube is equal to 1 mil. That is milliliter. So 1 cm cube and 1 mil are equivalent or they are same. Now, all I'm saying in essence is the rate of reaction is the speed at which reactants are converted to products or products being formed from reactants. Now, let me hypothesize a chemical equation. There's something I want you to get over there, or wherever you are watching me from. Look at this. In a hypothetical chemical equation, we have A plus B giving us C plus D. We take this as a typical example of what we mean by what? Chemical reaction. A chemical reaction must always go to completion in order to yield products. Unlike when we start talking about equilibrium reaction. Yeah. Equilibrium reaction is just a reaction that proceeds midway, most importantly. And of course, when we get there, we talk much about it. But for this, it must go to completion. Now, meaning there is no two about it. This side is the reactant, while this side is the what? The product. So that is it. And you see, for product to form, reactant must what? Disappear or must go into reaction. Yes, they must have the necessary energy that will make them to react according to collision theory and all that. Now, but you see here, in terms of reactant, rate of reaction is equal to negative change in A all over change in T, or negative change in B all over change in T. And in terms of product, rate of reaction is equal to plus change in C over change in T, or plus change in D over change in T. What does it mean? You see, whenever you are using reactant to express rate of reaction, you must attach negative. What does it indicate? That negative shows that reactant decreases at the cost of the chemical reaction. Or that negative shows that reactant must disappear for product to form. Now, what of the positive sign here? It shows that the cost of chemical reaction, products accumulate as reactant decreases, or product appreciate as reactant depreciates. That is just it. So that is why it is positive to the product side and negative to the reactant side. Because without reactant reacting, there is no product formation. Without reactant reacting. Now, of course, you may go to the exam. This is just how you will see it. But they may give you another equation of this. A this plus B giving you giving you C this plus D this. Our rate of reaction here we have what we call stoichiometric coefficient. These are the coefficient of the reactants and products. So coefficient of reactant A, that of B, that of C, that of D. Our rate of reaction will be, you always take the negative reciprocal of the coefficient. So you have minus 1 all over A, change in concentration A all over change in T, or minus 1 all over B, change in concentration B all over change in T. That is how to express rate of reaction here. But if you go to that of the product, you can put and for R in product will be plus 1 all over C, change in concentration C all over change in time, or plus 1 all over D, change in concentration D all over change in time. So that is it. You must always take the what? The reciprocal of the coefficients of the various reactants and products. Reactants and products. So that's how we go. These are the hallmark of your what? Exam question. Very important that you know the unit of rate of reaction. Or I told you simply change in concentration of reactant all over change in time, or change in concentration of product all over change in time. And you must know that concentration in chemistry is measured in mole per dm cube, or mole per liter. Then time is in seconds. So the unit of rate of reaction, don't forget, is unit of R will be mole per liter per second, or you have mole per dm cube per second. Very important. All these are what you are expected to know before exams, so that when you go there, you will not fumble yourself. You will do what is needful and come out with a victorious grade. As far as Unica is concerned, know these areas and you are good to go. Of course, like I said, follow me sequentially, because I'm going to unravel the hidden secrets revolving around chemical kinetic, and of course we extend it to other aspects of your chemistry topics. As far as Unica is concerned, follow through and you will pass wonderfully well.